Right now, as you're watching this video, sitting wherever you are, maybe with a coffee in your hand, maybe half distracted, there are two man-made objects flying through interstellar space. Not near space, not the moon, not Mars, interstellar space beyond our solar system, beyond the reach of the sun itself, and they have been flying without stopping for nearly 50 years. They are called the Voyagers. And here's the part that should genuinely stop you in your tracks. We are still talking to them. Every single day, scientists on Earth send signals across billions of kilometers of empty, silent space, and the Voyagers send signals back. We are having a conversation across the most extreme distance any human communication has ever traveled. Voyager 1 alone is more than 24 billion kilometers away. The signal we send to it travels at the speed of light, the absolute speed limit of the universe, and it still takes over 22 hours just to arrive. Another 22 hours for the reply to come back. Nearly 2 full days for a single exchange. So how on earth are we doing this? How are we still connected to something so impossibly far away? That is exactly what we are going to explore today. And trust me, the story of how the Voyagers got out there in the first place is just as mind-bending as the fact that we're still in touch with them.
4, 3, 2, 1. MDS, we have ignition, we have a liftoff.
Roll program is in on time. Vehicle response is normal.
Let's go back, way back, to 1977. The world looked completely different. People were watching Star Wars in theaters for the first time. The personal computer barely existed. And NASA was preparing to launch something that no space agency has ever truly replicated since. 2 spacecraft sent into the cosmos on one of the most ambitious journeys in human history.
You could see Voyager 2 is being tracked both by Antenna 35 and Antenna 36.
I think none of us knew when we launched 40 years ago that anything would be working for such a wonderful long journey.
They didn't launch at the same time, and they didn't take the same path. Voyager 2 went first, lifting off on August 20th, 1977. Voyager 1 followed roughly 2 weeks later, on September 5th, 1977. 2 different launch dates, 2 different trajectories, but one shared mission and one shared destiny that nobody at the time could have fully predicted. The mission was born out of a once-in-a-lifetime opportunity, once in 176 years to be exact. The outer planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, aligned in a way that made it possible for a spacecraft to use each planet's gravity as a slingshot, flinging itself further and further outward without needing to carry enormous amounts of fuel. NASA recognized this window and moved fast to take advantage of it. If they didn't, the next chance wouldn't come until the mid-22nd century. But here's what's important to understand. Nobody launched the Voyagers expecting them to become the greatest long-distance journey in human history. The original plan was focused on the outer planets. Study Jupiter, study Saturn, collect data, send it home. That was the mission. Get close, take pictures, learn something new, and call it a success. The idea of these spacecraft eventually drifting into interstellar space and still being operational decades later? That wasn't the plan. That was just what happened when you build something extraordinary and refuse to give up on it. And so, the Voyagers flew. Together, yet apart, following their own separate paths, but telling one continuous story. Both spacecraft swept past Jupiter first, and what they revealed was stunning. For the first time, humanity got a close, detailed look at the solar system's largest planet. We saw the swirling chaos of its storms, including its famous Great Red Spot, up close. We discovered that Jupiter's moon Io was covered in active volcanoes, something no one had confirmed before. We found that Europa had a surface of ice that hinted at something liquid beneath. These weren't just photographs, they were revelations that forced scientists to completely rethink what our solar system looked like. Then came Saturn. Voyager 1 made a close pass by Saturn's largest moon Titan, revealing a thick atmosphere that made scientists rethink what kinds of worlds can support complex chemistry. After that encounter, Voyager 1's path sent it upward and outward, away from the plane of the planets, away from any more flybys, and straight into the deep unknown. Its planetary story was over. Its deeper journey was just beginning. But Voyager 2 kept going. This is what makes the twin spacecraft story so remarkable. They each did something the other couldn't. While Voyager 1 headed into the dark, Voyager 2 continued the grand tour. In 1986, it became the first, and to this day, still the only, spacecraft to fly past Uranus. And in 1989, it did the same for Neptune, returning images of that deep blue, storm-swept world that remain some of the most breathtaking photographs in the entire history of space exploration. Together, the Voyagers gave humanity its first real look at the outer solar system, not through telescopes, not through calculations, but through actual close-up, eyes-on experience. That alone would have made them legendary. But they weren't done, not even close. Here's where the story shifts from impressive to almost incomprehensible. After the planets were behind them, both Voyagers simply kept flying. There was nothing to stop them, no friction, no resistance, just the quiet, relentless momentum of deep space. Years passed. Then a decade. Then 2. The sun, which once filled their cameras and powered the world they came from, became just another star in the distance, brighter than the rest, but no longer dominant. In 2012, Voyager 1 crossed a boundary that humans had theorized about for decades but never witnessed. the edge of the heliosphere, the vast bubble of solar wind and magnetic influence that our sun casts around the solar system. Beyond that boundary is interstellar space, the space between stars, the true open ocean of the galaxy. Voyager 1 crossed it, and in doing so, became the first human-made object in history to enter interstellar space. 6 years later, in 2018, Voyager 2 crossed that same boundary, taking a different angle, giving scientists a second data point to compare. For the first time ever, humanity had 2 spacecraft operating simultaneously in interstellar space. 2 pairs of eyes in a place no one had ever reached before. Today, both spacecraft are out there, silent to the eye, invisible against the stars but known. We know exactly where they are, we know their speed, we know their direction, they are not lost. They are just very, very far away. And yet, impossibly, we are still hearing from them. This is the part of the story that feels like it shouldn't be real. Voyager 1 signal, by the time it travels across more than 24 billion kilometers and finally reaches Earth, is so faint it has been compared to a fraction of the power used to run the smallest digital watch. That's not a strong signal that degrades a little. That is a whisper across the universe, arriving barely above silence, and we catch it. Through massive dish antennas positioned across different continents, a network specifically designed to always have at least one pointing toward deep space, we listen. And the Voyagers still talk. They send back data, they confirm their position, they receive our commands, and after a nearly 2-day round trip at light speed, respond. It's not a fast conversation, it's not a convenient one. But it is a real one, and it has been happening for nearly 5 decades. Scientists have had to get creative along the way. As the spacecraft's power slowly decreases year by year, teams on Earth make careful decisions about which instruments to keep running and which to power down, squeezing every last bit of life from machines that were never meant to last this long. And still, the Voyagers respond. The technology on board these spacecraft is older than most of the people sending it commands. The computers are less powerful than a basic calculator in your pocket. And yet they fly on, and we keep talking. So why does any of this matter? Because the Voyagers aren't just a science story or a technology story. They are a human story. They are the story of what a civilization can do when it chooses patience over convenience, curiosity over caution, and ambition over the fear of failure. Nobody in 1977 promised that these missions would last 50 years. Nobody guaranteed the signal would still be there. But people showed up, decade after decade, and kept the connection alive. Together, the Voyagers have shown us what our solar system truly looks like. They have crossed the boundary of our cosmic neighborhood and entered the wider galaxy. And they carry with them the golden record, a disk of sounds and images from Earth, a message to whoever or whatever might one day find them drifting through the stars. In a universe so vast it makes the mind ache, 2 small spacecraft built by human hands are still flying, still listening, still whispering back. The distance is incomprehensible. The signal is barely there, but the connection after all this time, it's still alive.